Hey everybody, welcome to this session. We're going to talk about cloud computing, edge computing, and WebAssembly. I am Alex. Great to join the conference today. We're going to talk about, we'll go through some quick history just to make sure we are all on the same page about cloud and edge and what is WebAssembly and all of that fun stuff. And then we dive into the WASM plus edge, and I'm going to also share practical real-world use case about doing WASM at the edge at Edgy, which is the company I work for. I'm Alex. I'm a software engineer from Italy. I've joined a few different companies in the last 10 years, from the e-commerce world at Cloud Academy to AWS for about 6 years, and today I'm a developer advocate at Edgy. I'll tell you more about what Edge is in a few minutes, but let's start from the fundamentals. What do we actually mean when we say edge computing? Because, in my opinion, it's quite a large umbrella term that can mean different things in different contexts. So what I want to focus on is the web development, the web world. If you're a web developer, if you build websites or APIs, edge computing probably means to you code that can run in an almost serverless fashion on top of global networks or content delivery networks, the Fastly or the Cloudflare of the world. There are a lot of other meanings for the term. You probably have heard about edge computing in the context of IoT devices or other subcategories of that world, like telecom, 5G, gaming, virtual reality, smart retail, smart vehicles. There are a lot of smart things where you take some computation that traditionally happens in a centralized data center and you try to move it somewhere else to the edge of the network on an IoT device, for example, or a smart device. We're not talking so much about that today, although some of the things that we see do apply. Now, to understand how we got where we are today about edge computing and all the things we'll talk about, it's important, in my opinion, to look at the cloud history. Now, this is very ancient history. If you're curious about that, pause the video, have a quick look. There are some interesting milestones in the last 50, 60, 70 years. I'm not going through all of that. Let's look together at some more recent history. In the last 15, 20 years, the cloud started existing. Around 2006, AWS came up. And then all the other vendors followed up, from Google to Azure to the open source world, and then Docker came. And if you look at the pattern, we went from bare bone virtualization to virtual machines that could start up in minutes in the cloud. And then we went from the virtual machines to containers, the Kubernetes and all the different managed container services out there. And about 10 years ago, in 2014, 2015, we went from containers to serverless functions. They coexisted. The two communities are now reconverging back together, luckily. But this idea of running functions in a serverless fashion where your code just spins up, runs for, 100 milliseconds and then shuts down. And so this different computing model came up about in the last 10 years, and they've been evolving together. Now, most of these vendors are just trying to sell you AI, but until a few years ago, they deeply cared about compute models and compute abstractions and what is the next thing. And another interesting evolution that happened kind of in parallel, but for some people, including myself, it happened behind the scenes without a lot of people noticing a trend, is the evolution of content delivery networks too. Most of these were born to provide simple content delivery or security, DDoS protection, for example. And some of these companies are as old as Google, from 1988, 1989. Akamai, for example, was born the same year as Google. So they've been around for a lot of time, and there used to be various ways to implement custom logic on top of these global delivery networks that were optimized for, again, delivering content, caching content, helping you with streaming, especially in the last few years. That grew a lot. Maybe you've heard of things like the Varnish configuration language that allow you to do more dynamic logic directly at the edge. But so this was the edge until, say, 10 years ago. People used CDNs for caching. But then something happened, and look at the years. It's all about 2016 to 2019. this idea of running the Edge workers or the Cloudflare workers or the Lambda at Edge or CloudFront functions in the AWS world or the Fastly Compute platform. The idea of running code directly on top of the hundreds and hundreds of points of presence became more and more popular. And this all kind of aligned to the revolution of the serverless mindset, where you could just spin up a function, run it, take care of some business logic in a few milliseconds, and then shut down. So it aligned to that change after 2014, 2015. Now, there are many different technologies behind the hood. And another interesting fact is that when you finally have compute somewhere, it's not long until you have additional services like key value store, databases, ad hoc domain-specific services like image optimization and compression. You have databases, queues, object storage, configuration management services, and so on. So if you look at this from the perspective of the cloud computing world, it's almost as if, and some people will tell you it's exactly as if, many CDN providers became cloud computing providers themselves, because now they offer you not just caching and CDN and content delivery, they offer you everything from compute to databases, queues, object storage, and so on. So the difference between edge computing and cloud computing is blurring if you see the pattern that happened in the last few years. Now, another interesting pillar of this talk is WebAssembly, where if you have never heard of it, don't worry, I'm going to try and cover the basics and make sure everybody's on the same page. If you have never heard of it, I believe it's possibly one of the most interesting development in the web space of the last few years. And as we'll see later, some cloud and edge providers already allow you to deploy WASM applications to their computing platforms. To recap its evolution, it was announced in 2015 and then released in 2017. So it's been around for a while. It became a W3C recommendation in 2019. That's a bit more recent, and there is still a lot happening. So it's still evolving, it's still changing, and adoption is still growing. So a lot of people talk about WebAssembly in the context of running binary files in the browser. And that's amazing. You can do incredible things where you compile a super efficient C or Rust or Go library or algorithm into a binary file, a WebAssembly file, that then you can take and run anywhere else because you have full portability. And one of the places where you can run this is in the browser. But that's not what we're talking about today. We are talking about server-side execution of WebAssembly, which also has a lot of potential, including at the edge, of course. Now, you may already know the WASM supports a lot of different languages, from Java to TypeScript, PHP, C#, Go, Rust, and so on. It's probably the most interesting and more common pattern is where you implement something complex or computationally complex in a compiled language like C, C++, Rust, or Go, and then you use that WebAssembly component or WebAssembly module into another language, since you have full portability. Now, some mandatory quote here in 2019, when it reached W3C recommendation status, the founder of Docker wrote that if WASM and WASI, and we'll see what WASI is in a second, if they existed back in 2018, they wouldn't have had to create Docker in the first place. So this is just to give you some perspective of how much potential there is and how much the industry is trying to adopt it and see what's possible with it. Now, there is a lot of online documentation. Most things in the WebAssembly, if not all things, are open source. So you'll find design decisions on GitHub and a lot of documentation. The second interesting part of the full picture, in addition to WebAssembly, is WASI, which is the WebAssembly System Interface. It's basically a collection of APIs that allow a WASM runtime to interact with the operating system. So you get all the benefits of interacting with the file system, with the network, with threading APIs, sockets, all the operating system calls that you would normally not have in WASM. Now, the vision for some people here is that WASM will become the de facto standard for backend development. And that's a bold vision, right? It's hard to replace the Docker or the Kubernetes, but they are actually already coexisting. If you look at some of the registries and services up there already support WASM containers, for example. There is also the WASM component model, which is a more recent way to build not modules or entire applications, but components that are meant to be composed and reused across applications and modules. Now, some of the benefits that you may have heard, but let's dive a bit deeper. You have full portability. When I compile into WASM, I can take that binary file and use it literally anywhere in other operating systems, in other architectures, and so on. So this is kind of the dream. You probably saw it decades ago with the Java world as well. Difference is here the kind of layer of the operating system is much smaller, and the startup time is super fast, and you get near native performance. So some of these benefits are super useful for cloud and edge deployments, as we'll see later. Another, and probably my favorite, another interesting feature of WASM is that you have secure sandboxing by default, meaning your code doesn't have access to anything by default. So it can't just do an HTTP call or a file system call. You have to explicitly provide access to those APIs. And that's incredibly useful, especially if your final goal as a vendor, as a provider, as a platform, is to be able to run untrusted code. And we'll look into that later. Now, let's look into the Go support. WASM has been supported as a target since 2018, since version 1.11. The official tool chain here also provides JavaScript utilities to facilitate running WASM modules in the browser, if that's what you want to do. For many people like us at Edgy, we are doing only server side, so that's not super useful. I'm also sharing some links. Feel free to check them out to dive a bit deeper into some of these topics. Now, the component model and the WASI support is a bit behind. It's been in experimental status since 2023 in version 1.21. So the WASI Preview 1, there are currently two WASI, the P1 and the P2, but there is support for WASI P2, so the Preview 2 of WASI in TinyGo. So typically you want to do a TinyGo application, or you want to use TinyGo to compile, and an additional thing you probably need if you're using your own interfaces or even the default ones is that you want to use with bindgen Go to generate the kind of the bindings for the interfaces. And so there is a lot of code generation involved as well. With is the way that you define interfaces in the WASI world. So you pretty much have some standard interfaces that interface with the operating system, like file system sockets, HTTP, network calls, clocks, randomness. And so you can also define your own with interfaces, because this is an actual interface definition language. So for example, that's something we are doing at Edgy as well. We are defining our own domain-specific interfaces so that we can then allow developers to build their own components that implement the interface that we defined, and we can run those components in our platform. Another interesting development from, I think, a couple months ago, a few weeks ago, is that Google announced expanded support in version 124 of Go. So there are better ways to export functions to Go functions to WebAssembly. And so that allows you a deeper integration with the WebAssembly host. That's super useful if you are building modules or components. In the same article, and this is something I initially missed myself, they also announced that WASM at the edge is supported in the Google Cloud platform. This is super interesting because they now allow you to use service extensions implemented in WebAssembly in their application load balancer. So you can add custom code and custom logic in the path of the request response path. I think that's an incredibly cool example of what is possible with WebAssembly, and also how cloud providers or platforms in general can use it to extend the service capabilities. Now, of course, you also find official WASM runtimes, for example, WASM time here. And these runtimes are explicitly designed for speed and security and easy of configuration and WASI support. So you don't have to re-implement the wheel every time, just add a little layer of WASM runtime, and that simplifies a lot of things. So for example, here WASM time is designed and developed by the Bytecode Alliance. If you've never heard of the Bytecode Alliance, they are a non-profit. They're working on a lot of different toolings like compilers and runtimes and additional language-specific tooling for WebAssembly. They are supported by a lot of tech companies out there. You probably recognize some of the logos. Many of these are cloud providers, Edge, CDN providers, or even WASM, native WASM platforms. So there is a lot of work happening in this space. Feel free to check it out on the website as well. Now we have the basics. We know everything about edge computing and how we got here with the compute platforms and with all the additional services. We know about WebAssembly and where it's going and how is the Go community integrating it more deeply. Now, what I find super interesting about this combination of Edge and WebAssembly is that with edge computing, you have an incredible advantage that your code is, or your application is globally distributed by design. So by default, when you push code to the edge, it will run on hundreds and hundreds of edge locations or POPs, points of presence. And that's a big difference compared to the cloud. That's interesting to be aware of, because usually an architecture starts as a centralized or monolithic application that runs in a single data center or maybe in a 2 or 3 availability zones within a cloud region. And that's super convenient. You probably don't need more than that. But especially if you're building a website or a product with a global audience, you quickly, very quickly end up using or involving some kind of CDN for caching and distributing. That's like a architectural best practice. And so you want to distribute and cache and even run code as close as possible to your final visitors, to your final users and customers. And I find it very fascinating that with edge computing, all of that happens automatically. And so your edge applications are globally distributed with a couple of clicks. If you compare that to the cloud, it's been increasingly easier to do in the last few years. It's still not the same, in my opinion. Now, another interesting technical trade-off to be aware of is that usually at the edge, you have less compute power and you have less resources in general compared to a virtual machine where you can have gigabytes and gigabytes of RAM or a container or even a serverless function. Also, things really need to happen quickly because often your edge compute logic runs before and after every single HTTP request. So if it takes you 20 or 50 or 100 milliseconds to run, it means that you're probably adding additional latency to every single HTTP request. And that's not great, right? You want to run as fast as possible. So normally you want to run your edge logic in 5 to 10 milliseconds. And that's really fast. If you think about it, if you have to talk to a queuing system or a database or a key value store, you really need to be quick. Now, while it's true that some edge and CDN providers are making this less of a problem, most edge deployments need to be aware of this kind of technical constraints or limitations or trade-offs. For example, Bunny.net recently announced their Magic containers just a few weeks ago. And also Akamai seems to be pushing a lot their managed container service in their cloud, which is actually distributed like the edge. So there is a lot happening also in this space, and being aware of the trade-offs and the pricing limitations or differences is really useful in my opinion, especially if you come from the more traditional cloud world and you're used to typical traditional virtual machines, for example. Now, if you remember the WASM key benefits that we saw earlier, there are 2 or 3 of these that are really important for the edge, especially the near native performance. Again, we need to run as quickly as possible within just a few milliseconds, ideally. 2, 3, 4, 5 is great. If you go above 10, 20, or 50, it becomes a problem. We also have that very small size and very fast initialization because we cannot afford seconds and seconds of startup time or cold starts like you typically have with containers. It could take tens of seconds to spin up a container, or it could take hundreds of milliseconds to spin up a serverless function. Typically at the edge, we can't afford that, so we need to be even faster. And then we love the security sandboxing for the edge, especially if you are running, again, untrusted code and you want to limit network access, because it might become problematic if you need to fetch an external API call and it takes 2 seconds or half a second. Even half a second is a lot. Now, that's why we chose this interesting match of WebAssembly and edge computing at Edgy. And as you can guess from the name, we are doing a lot of stuff at the edge. In a nutshell, we are building a platform for application level services powered by edge computing and WebAssembly. Let me tell you a bit more. The core service that we've been working on so far is really focused on data collection and web analytics, but that's just the starting point. The final goal for data collection and web analytics is to allow our customers to transform those typical heavy client-side SDKs, like for the Google Analytics or Segment or Amplitude, things that you have to do traditionally, have to do on the client somewhere else. So we want to take advantage of the edge and transform those SDKs into WebAssembly components that can run even before the page is sent back to the browser. So this allows zero latency, very secure and unblockable data collection. So it is solving an actual business problem. If you are a website owner, you want to take decisions based on how people use your product or what content they are consuming on your platform. This is important to make sure you can make data-driven decisions that make sense. And again, this is just a starting point. We're working on new types of components in the future to support additional use cases. Data collection is the core, but we are adding A/B testing, feature flags, AI inference, and a lot more use cases in the future. We also created what we call the Edgy component registry. And this is basically a registry for WASM components running at the edge. So this is just very new from a few weeks ago. As a developer now, you can build, push, and share a WASM component and then allow anybody to use them directly on the Edgy platform. And this is super cool, I think. All of these components are open source. Even the proxy of the Edgy proxy itself is open source. And so what we're trying to do here is create a nice community of contributors and component developers that can build and share these components. So you can think of this as a domain-specific registry for WebAssembly components where you can discover and push either private or public components for yourself, for your customers, for the whole community to use. Now, we also invested a lot in developer tools. It's not just uploading files in a website or invoking APIs manually. We wanted to make the developer experience as easy, smooth, and pleasant as possible. So we built some developer tools like the Edgy CLI to allow you to support all the different languages. Of course, Go is supported. We also support Rust and Python and C# and TypeScript and so on. The goal of the CLI really is to allow you to build and test locally whatever language you're using and then easily push your component to the registry. It is also open source. And I also wanted to show you what this actually looks like. So you can very easily install it. There are different ways to do it. And then you create a new component. So for example, let's choose Go. It will auto-initialize all the with dependencies. And then you implement the business logic and compile to WebAssembly. It's all one command, Edgy component build, and it magically does the work for you of generating the with bindings and running the compile into WASM. And then you can finally test locally and make sure that your code is behaving properly. And when everything's ready, you Edgy component push into the registry, and your component, if public, becomes available to everyone out there, or even maybe you push it as a private one and it becomes available to your organization or your customers. So this is really cool. I also wanted to share with you a little bit of the high-level architecture, what this all looks like. I already showed you what the super high level looks like. So you have the client devices, you have the Edge proxy running on Fastly today. We are expanding soon to run on other CDNs like Cloudflare and so on. And then the proxy is there in between the client devices and the website, the final website. And so there is a lot happening behind the scenes because not 100% of the logic can happen directly at the edge. We have some kind of backend services and managed consoles and APIs and so on. For example, the Edge proxy is talking to an event API, which takes care of actually running the WebAssembly components and integrating with third-party APIs and third-party platforms. And then you have the public website, you have the Edgy CLI, and potentially other API consumers who talk to the Edgy API as well. And as you can imagine, the Edge behavior needs to be customizable. So the Edgy API itself needs to be able to interact with the proxy and provide customizations and configurations directly at the edge. And there is a lot going on. Our long-term vision here is to be able to run even more of the WebAssembly things directly on top of the Edge proxy, on top of CDNs. There are some technical limitations today as far as the component model support. So we are ending up creating our own distributed network across multiple clouds, across multiple compute models. For now, we are focusing on AWS Lambda because it's helping us go fast and scale when needed. And so that's what I had for you today. I want you to remember that CDNs are not just for caching and DDoS protection anymore. There is a lot more compute capacity and application level services like databases, object storage, and so on. The Edge is providing a new way for building applications, especially globally distributed applications and functionalities. WebAssembly and WASI have a very bright future, in my opinion, and we are investing a lot on it. There is a big community focusing on tooling and improving the experience and adding support for even more languages. If you're interested into the idea of a component registry and you want to contribute and create your components, feel free to join our community. You can push for free. There is a free tier that allows you to do a lot and experiment as a developer, and then we can talk business as well. Thank you for joining this session. I'm Alex from Edgy. You can find me on LinkedIn or on other social media. Feel free to reach out. I hope you learned something new today and have fun with WebAssembly and the Edge. Bye-bye.